Hello and welcome to the session of 8085 microprocessor programming model. In the earlier discussion, we had a look over the architecture, inner details, inner register arrangements and memory communicating arrangements through address and data lines, IO communication lines. Then we have looked over the pin description of 8085 microprocessor. Whenever we start or whenever we intend to learn about any processor design, we can learn it in few classifications. One is through its architecture and block diagram, another is through its programming model, and another is through its timing representation. So if we look over the programming model of 8085, it has 16-bit address lines and it has 8-bit data lines, and based on this it can go for operating some set of instructions. If we go with a simple understanding, like what is this slide represent is how addressing is done through the obtained address lines. If we have one address lines, we can map up to two locations. If we increase the count of the locations, the size of the address locations also increase. But if we increase the size, not count, if we increase the size of the locations, we need not increase our address line. So this is the strategy. The size indicates the capacity of data, the count indicates the addressing lines. So based on this, if we go with respect to 8085, the memory operations or addressing of 8085 happens with the help of 16-bit address lines, through which we can go up to a mapping of 2 power 16 locations, 64 kilobytes or 64 KB, nothing but something around 64,000 locations, and the capacity of each location is 8-bit. So it can be represented as 64K by 8 in matrix format, and each location is represented using some 16-bit address lines. 16 binary address lines can be written in 16 binary bits format or 4 hexadecimal bits representation. Something shown as an address 1000 can be written in this format. In this 64 KB locations, each location will be holding 8 bits. So count of bits here are not data, this is address lines, and internally it will be having a position of only 8 bits. So addressing is done in this way. Sometimes if you want to access more than 8-bit, is 8085 sufficient to operate on that? Answer is yes, we can go for more than 8 bits up to 16-bit or some other count with respect to splitting of data and representing it in a format of 8-bit. So if we directly look over the programming model, any programming model will be utilized based on its addressing modes and instruction set. Now how it happens while generating the address and instructions. So what we see on the screen here is a clock representation which will be continuously going on after the power supply. Whenever we generate an address, the procedure is given in this pattern, showing like along with the address, as mentioned earlier, a strobe signal will be generated to indicate that the address is valid address. Similarly, we'll be having the next procedure is after obtaining the address, either we have to give the data or get the data. How can we do these operations using a program? So that is what we are representing in the programming model. So the first thing that happens with programming model is it will be having an instruction format which will be a combination of opcode and operands. Operands are those that are similar as data, and where these data is located, it is been obtained. So getting of the data and performing some operation on the obtained data is done through opcode. Whatever operand we have obtained, we will operate it through some set of instructions, set of operations titled as opcode. Getting or obtaining the data is treated as the way of addressing the data, addressing mode. Operating using some set of opcodes, we together club into instruction set. This is a set of programming model. So it will be branched as addressing mode and combination of instruction set. So how such addressing modes, or how many such addressing modes we have for 8085, we can have a quick glance here, representing as data can be utilized directly, data can be utilized through some sources. If we obtain the data directly through the instruction itself, we consider it as immediate addressing mode. A representation is given like this: MVI, move immediate data to the register. Then again we will have a register addressing mode, through which we are going to obtain our required operand in the destination register through some source register. Or sometimes we can obtain this data through some memory locations as represented here. Sometimes we may require our data by going from one memory location to another memory location, which we in other terms consider it as indirect addressing mode. Each addressing mode will be having its own prominence, its own importance, and own comparison with the other addressing capacities. In the same flow, if we go with some more discussion, the second half of programming model, instruction set, various opcodes that are being utilized for working on instructions or working on operands are categorized based on their functionality. The major headings that we can utilize or make them in classification are mentioned as data transfer instructions, arithmetic operation instructions, logical operation instructions, or shifting, branching operation instructions. So if we have a list of data transfer instructions, we can state them as in, out for port operations, move for data or memory operations, MVI for immediate operations, halt for stopping the operation. These are all shifting the control of program or shifting the data of program from one place to other place. We consider them under data transfer. A list of arithmetic also is been shown here, representing basic arithmetic operations: addition, subtraction, increment, decrement. We don't possess multiply or divide in addition at the time of design of 8085. Some other list of instructions under logical category and or XOR operations. In continuation with the shift and rotate operations, we will have RL rotate left, RLC rotate left through carry, RR rotate right through carry, shown with an opcode called RRC. Another interesting instruction here is CMA, compare the content or complement the content of accumulator. So branching instructions, which are again categorized, are unconditional and conditional. Branching happens whenever the control of the program or flow of the control of the program is to be shifted from one place to other place. Unconditional instructions are those that shift the control without any condition satisfaction. So jump and call perform unconditional branching. The difference between them is whenever we shift our operations from jump to call will be utilized to come back to the place where we have shifted using return operations. And RETI is one such arrangement which will help us to come back to our main routine whenever we have to encounter a interrupt subroutine operation. So these are some of the representations with respect to the programming model of 8085. Utilizing this, we can frame simple or high-end programs, and we can also learn about the time flow, how the instructions are being dedicated with respect to time operations. In the coming video, we can have a simple basic level program discussion on how 8085 operates through its programming model. Thank you very much.